Have you ever pondered the intricate workings of the cosmos? The cosmos, a realm so vast and unfathomable that it renders our minds incapable of truly grasping its magnitude. This celestial expanse is filled with countless galaxies, each teeming with a myriad of stars, planets, and other celestial bodies. Yet, it is more than just a grand display of astronomical wonders. We often find ourselves grappling with the complex laws of physics that govern this space. The principles of gravity, time, and space that we've known for centuries are thrown into question when we step into the mind-boggling world of quantum mechanics. Quantum mechanics, a field of study that probes the interactions of particles at the molecular and subatomic levels, introduces new dimensions to our understanding of the cosmos. It presents a paradigm shift, challenging our conventional perspectives of reality. This subatomic domain is a cacophony of uncertainty and paradox, where particles can exist in multiple places at once, and matter behaves like waves. The dance of the universe may not be as predictable or orderly as we have believed. It is a dance dictated by the strange and compelling laws of quantum physics, where the steps are spontaneous and the rhythm is serendipitous. This exploration of the cosmic mysteries is not for the faint-hearted. It's a daring journey that requires courage and unyielding curiosity. It demands that we question what we think we know, and bravely venture into the unknown. So, what if the universe dances to a tune that's different from what you've always known? Brace yourself, as we delve into the enigmatic realm of quantum mechanics. Quantum mechanics, a cornerstone of physics, grapples with the behavior of matter and energy at their most minuscule. It's a sublime field, crafted on the detailed intricacies of the universe, seeking understanding of particles and waves at the atomic and subatomic level. The beauty of this profound theory lies in its ability to explain the inexplicable. Its purview extends to the infinitesimally tiny, to the very building blocks of life and reality. Quantum mechanics dwells on the concept of duality, positing that light and matter exhibit properties of both particles and waves. It explores the quantum state, a superposition of possibilities that exists until observed or measured. Moreover, it introduces the principle of quantum entanglement, where particles become interconnected, with the state of one immediately impacting the other, regardless of the distance between them. It's a dance of cosmic proportions, a ballet of subatomic particles choreographed by the laws of the universe. Quantum mechanics deal with probabilities, suggesting that our universe is fundamentally uncertain, breaking down our notions of realism. It has even led to the development of quantum computing, quantum cryptography, and quantum teleportation, driving innovation in technology. It peels back the layers of the universe, exposing a complex tapestry of probabilities and uncertainties. At the heart of quantum mechanics lies the principle of superposition. This foundational concept is what sets quantum physics apart from classical physics. It is a principle that is so mystifying, so astonishing, that it seems to defy the very logic that our minds are hardwired to understand. The principle of superposition proposes an astounding idea. Those infinitesimal building blocks of matter have the capacity to exist in several states simultaneously. They are not confined to a single state until they are observed or measured. Now let's try and comprehend this. Visualize an expansive ocean, its waves symbolizing a multitude of possibilities. Each wave, each particle, can exist as a crest or a trough or anything in between. They are not bound to any single state. They can be everywhere and everything, all at the same time. Such is the nature of particles in the quantum world. This is not a figment of theoretical imagination, but a reality supported by experimental evidence. It implies that every possible outcome, every potential state of existence, remains feasible and viable. And this sea of infinite possibilities continues its undisturbed existence, maintaining its multitudinous states, until the point when an observation or measurement is made. It is only at that staggering moment of observation that these particles snap into one state, one reality. Imagine a sea of possibilities, where every outcome remains viable until the moment of observation. Then, there's the phenomenon of entanglement. This is an intriguing and perplexing aspect of quantum mechanics, a field known for its esoteric and unorthodox principles. In this unique situation, a pair of particles are so intrinsically linked, they start to mirror each other's behaviors and characteristics. This correlation persists, no matter how far apart they are spatially. It seems that, once entangled, these particles form an unbreakable bond, one that transcends physical barriers and conventional scientific understanding. Now, what makes this truly fascinating is the instantaneous nature of this influence. It's as if these particles are always in a state of continuous and immediate dialogue, effortlessly overcoming the limitations set by our conventional understanding of space and time. It's as though these particles are in constant communication, defying the confines of space and time. Quantum mechanics further proposes the idea of uncertainty. This is a realm of science that has left even the most brilliant minds puzzled and intrigued. The principle suggesting this uncertainty was conceived by Werner Heisenberg, a German physicist and one of the key pioneers of quantum mechanics. Heisenberg's principle, often referred to as the uncertainty principle, is a fundamental theory that has revolutionized our understanding of the microscopic world. The uncertainty principle articulates certain limitations on our knowledge about the behavior of subatomic particles. It suggests it is fundamentally impossible to simultaneously and accurately determine both the position and momentum of a particle. This is not due to any flaw in our measurement tools or techniques, but a result of the inherent uncertainty that exists in nature itself. This principle introduces a world where certainty about a particle's position inversely affects the certainty of its momentum and vice versa. The more we discern about one attribute, the less we comprehend about the other. This concept has certainly changed the way we perceive the world at the quantum level. So, what implications do these concepts have for our universe? These theories and principles propel us into an unfamiliar realm of understanding, one that relentlessly challenges our long-held perceptions and beliefs. They shake our comprehension of foundational aspect of life itself, cause and effect, allowing us to speculate a reality beyond the conventional. Diving deep into these concepts, we find ourselves in a realm where the conventional laws of physics seem to be merely an illusion, where entities bear the power to coexist in multiple states simultaneously, defying the universally accepted concept of singularity. It's an existence nuanced with complexity and layered with paradoxes, one where the physical distance between bodies becomes irrelevant, challenging our very understanding of separation. In this dimension, certainty, a humanly craved constant, becomes nothing but a mirage, shimmering with false promise yet delivering no concrete truth. They reveal a world where entities can exist in several states, where separation is inconsequential, and where certainty is a mirage. Unraveling the enigma of quantum mechanics allows us to peer into the universe's fabric. This is much more than your high school physics. We are no longer talking about simple concepts like gravity and motion. We have ascended to the realm of quantum mechanics, a mysterious and fascinating world that operates on its own set of rules. It's like opening a window to a world that's both micro and macro in scope. It is the world that governs the behavior of particles smaller than atoms, yet it has far-reaching implications for our understanding of the universe. It's a world where particles can exist in two places at once, and where observing a particle can change its state. Quantum mechanics is a key that opens up a new frontier. A frontier that's filled with infinite possibilities and infinite questions. It's like standing at the edge of a grand precipice, peering into the vast unknown. This is not just about scientific curiosity. It's about pushing the boundaries and expanding our horizons. Advancements in this field can open doors to new technologies, unimaginable in the past. Imagine computers thousands of times faster than anything we have today. Imagine teleportation, not just of information, but of tangible physical objects. These are not mere fantasies, but real possibilities opened up by quantum mechanics. We can push the frontiers of science and explore technological potentials. So, when you next stare into the starry expanse, take a moment to contemplate its immensity. Consider the mysteries that lie in wait within its vast depths. Think about the countless galaxies, each with millions of stars, each star potentially harboring its own unique planetary system. Consider the enormity of the cosmos, the countless number of celestial bodies, each with their own tales untold. Do you ever ponder what these stories might be? The tales of planets unseen by human eyes, of civilizations that might be thriving in distant galaxies? Or perhaps they tell tales of cosmic phenomena that we have yet to even comprehend. The universe is an enigma waiting to be unraveled, its secrets cloaked in the darkness of space, yearning to be unveiled. And that unveiling can only come through exploration, through questioning, through observation, and through discovery. By subscribing to our channel, you are embarking on this journey of discovery. Each video we produce is crafted with fervor, designed to stimulate your curiosity and to satiate your thirst for knowledge. So hit that subscribe button and join us on this quest to uncover the secrets that the universe holds. Each time you gaze into the night sky, remember our shared quest. Remember the excitement that comes with each new discovery, each step further we take into the unknown. And always remember to thank yourself for your insatiable curiosity, for it is the driving force behind all progress and discovery. And, as always, thank you for tuning in.